So let's start with number 3. You're going to have a question on the test where you have to verify. So you're going to get everything that's on the last page on the review. You'll get all your identities. When we verify, we're going to put a brick wall right down the equal sign. Our goal is to make the left side of the equation the same thing as the right. Any suggestions of what we could do here? Awesome. We can change secant squared minus 1. So let's look at our identities. So we're going to change this equation here. We want it to look like secant squared minus 1. So what would I need to do to make it look like secant squared minus 1? Subtract 1 to the other side. So we have tangent squared equals secant squared minus 1. So I'm going to replace the secant squared minus 1 with tangent squared. So we have cosecant squared times tangent squared. Now remember, with these questions, it pretty much gives you the answer. It tells you what you're going to simplify to. Your job is to show the work. You need to show every step that you're doing. So make sure you're super clear with the work, because that's what you're getting graded on. If I can't follow your steps, I can't give you the points. What should we do next?
You could break tangent to sine over cosine, and then CSC to sine.
Awesome. Let's change everything to be in terms of sine and cosine. So we have 1 over sine squared times, what's tangent squared? Sine squared over cosine squared. Anything simplify here? Cross out the signs. So we're left with 1 over cosine squared. What's 1 over cosine squared simplified to? Secant squared. So there's only 3 verifying questions from the review, but if you want more practice, go back and look at the WebAssign. That's good practice. Also, your simplifying quiz review from the 5.1 quiz review will be super helpful with the verifying stuff too. Next, let's look at number 4. So we're going to solve here. So make sure you pay attention to the directions between verifying and solving. Solve, we want to find what x equals. So we have to get our trig function all by itself. What should I do first here? Add 3. So tangent squared x equals 3. What should we do next? Square root both sides. So tangent equals what? Plus or minus square root 3. Don't forget the plus or minus, because if you miss out on that plus or minus, you're missing out on half the answers. So plus or minus square root 3. Let's put our unit circle here, so now we can find the tangent. So tangent, we look at what on the unit circle? Y over x. So I want to see, where is y over x square root 3? Positive or negative? Square root 3. So we always want to do the math in the first quadrant to see what these values will give us, because it's going to repeat in every quadrant after that. So y over x for pi over 6 would be 1/2 over square root 3 over 2. So when we keep change flip here, this would give us 1 over square root 3. Y over x for pi over 4 would just be 1. And then y over x for pi over 3 would be square root 3. Now you can do the math every time to find these, but it's going to be the same thing every time. If you just want to memorize these 3, you could do that too. So you're just finding your y over x and keep change flip. We're looking for square root 3, so that's going to be pi over 3. Where else would tangent be square root 3? Positive or negative square root 3? What's our denominator? 3. So it has to be the ones that end in 3. 4 pi over 3. This will also give us positive square root 3, but we're looking for positive or negative. 2 pi over 3 would give us negative square root 3. Perfect. Anywhere else? 5 pi over 3. So it's always going to be the ones with the same denominator. This would be negative square root 3. And since it's positive or negative, we're including all of them. So we'd say x equals pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Any questions here? So with number 10, we have different trig functions here. What could we do? We can move the 10 cosine to the other side, so I'm going to subtract 10 cosine x. But we like it when our trig functions are the same. So how could I make these be the same trig function? Which one can I change here? I can change the sine squared. So you want to change the squared one because you're going to use your Pythagorean identities. So when we change the sine squared, let's figure out what sine squared is equal to. Our Pythagorean identity is sine squared plus cosine squared equals 1. So to get sine squared all by itself, we're going to subtract cosine squared. So sine squared equals 1 minus cosine squared. We're going to take 1 minus cosine squared and substitute it into the sine. So that 8 stays outside. When we plug it in, we're putting it in parentheses. So 1 minus cosine squared x minus 10 cosine x minus 11. Now we have the same trig function. What can we do next? Distribute. So 8 minus 8 cosine squared x minus 10 cosine x minus 11 equals 0. What else could we do? Combine like terms. 8 minus 11 would be what? Negative 3. So we have negative 8 cosine squared x minus 10 cosine x minus 3 equals 0. What could we do next? Awesome. We're going to have to factor. I don't like to factor when our leading coefficient's negative, so I'm going to divide everything by -1. It's just going to make the math easier for us as we go along problem. So we have 8 cosine squared x plus 10 cosine x plus 3 equals 0. Now how would we factor? Awesome, multiply the first times the last. So 8 times 3 would be 24. What are two factors of 24 that add to 10? Add to 10. Four and 6. 12 and 2 wouldn't work because one of them would have to be negative, but they multiply to positive 24. So be careful. So 4 and 6 works. So we have cosine plus 4 times cosine plus 6. Now if we start by multiplying, what do we have to remember to do? Divide. So we're dividing both of these by that first number, 8. Simplify the fraction if you can. So we have cosine x plus 1/2. If it doesn't simplify, move the denominator in front of the x. So simplify as much as you can. If it doesn't simplify anymore, move the denominator. So this would be 2 cosine x plus 1. The next one simplifies to cosine x plus 3 over 4, because we can divide them both by 2. So then we want to move the 4 in front. So 4 cosine x plus 3. What can we do next? Set them both equal to 0. So set them equal to 0 and solve. I'm going to do 2 steps in one here. So we're going to subtract the 1 over and divide by 2. We get cosine x equals -1/2. and cosine x equals negative 3/4. What do we do from here? Let's look for it on the unit circle. All right, so cosine tells us we look at what on the unit circle? The x. So I want to see, where do I have an x value of negative 1/2? Two pi over 3. Anywhere else? 4 pi over 3. Perfect. So we have x equals 2 pi over 3 and 4 pi over 3. Now we're going to do the same thing with our second equation here. We're looking for where we have an x value of negative 3/4. Do we have any x values on our unit circle of negative 3/4? No. So this one's not on the unit circle. So we only have two answers. So looking at number 11, here we already have the same trig function, so we don't need to convert anything. What can we do to solve here? Let's factor. What are two factors of negative 2 that add to negative 1? Negative 2 and positive 1. So we have cosecant plus or minus 2 and cosecant plus 1 equals 0. What should we do next? Set them both equal to 0. So we have cosecant equals 2 and cosecant equals negative 1. What do we do next? Let's look on our unit circle. So cosecant is the reciprocal of which trig function? It's the reciprocal of sine. So I'm going to flip the left side to be sine, but if I do that, I also have to flip the right side too. So let's do the same thing with the other one. We're going to flip cosecant to be sine, but we also have to flip negative 1. What would negative 1 flip to? Same, negative 1, because it'd be negative 1 over 1 when we flip it. 1 over negative 1 is still just negative 1. So we're looking for where sine is 1/2 and where sine is negative 1. Sine tells us we look at what value on our unit circle? The y value. So I want to see, where is my y 1/2 and where is y negative 1? Let's see. Here's our unit circle. So where do we have a y value of 1/2? Pi over 6. Anywhere else? 5 pi over 6. Perfect. So those will be our first two answers. We can say x equals pi over 6 and 5 pi over 6. And then we also want to see where we have a y value of negative 1. So going back to our unit circle, where do we have a y value of negative 1? 3 pi over 2. Anywhere else? Nope, that's it. So we're going to add 3 pi over 2 to our answer sheet, or our answer list. So these are our answers. So number 16 is one of those multiple angle ones. We have sine of 3x. That 3 is attached to the sine until we get sine all by itself, until we actually look for it on the unit circle. So we want to move everything else to the other side. So what can we move first? Add the 1 and divide by 2. So sine of 3x equals 1/2. What can we do next? Awesome. Sine tells us we're looking for the y, so we want to see where on our unit circle is our y value 1/2. So you said 5 pi over 6? Yep, our y value is 1/2 there. Anywhere else? Pi over 6, perfect. So instead of just saying x equals pi over 6 and x equals 5 pi over 6, we have that 3 now. So this is where we deal with our multiple angle. We're going to say 3x equals pi over 6 and 3x equals 5 pi over 6. Now we have one more step that we do at the very end. What do we have to do next? Divide by 3. So I'm going to divide both of these by 3. But what do we do when we have a fraction in a fraction? Keep, change, flip. So the same thing as dividing by 3 is multiplying by 1/3. So when we flip it, it changes to multiplication and flips to 1/3. So what would we get? Pi over 18 and 5 pi over 18. Sometimes these might be able to simplify, so always check to see if you can simplify your fraction at the end. Here we can't simplify anymore, so this is our answer. What should we do with number 14? Perfect. We're going to change the one that's squared. So we can use our identities, but you have to change the one that's squared. So sine squared, let's find out what it's equal to. Our identity is sine squared plus cosine squared equals 1. So to find what sine squared is all by itself, I'm going to subtract cosine squared to move it to the other side. So sine squared equals 1 minus cosine squared. We're going to take 1 minus cosine squared and substitute it into the sine squared. So we have negative 2 times 1 minus cosine squared. Plus 3 cosine plus 3 equals 0. What could we do next here? Distribute the negative 2. Perfect. So we have negative 2 plus 2 cosine squared plus 3 cosine plus 3 equals 0. What could we do next? Combine like terms. So negative 2 plus 3 would be 1. So we have 2 cosine squared plus 3 cosine plus 1 equals 0. Now what can we do? How do we factor? Multiply the first times the last. So 2 times 1 would be 2. What are 2 factors of 2 that add to 3? 2 and 1. Perfect. So cosine plus 2 and cosine plus 1. What do we have to remember to do next? Don't forget to divide by that first. If you start by multiplying the first times the last, you have to remember to divide by the first. So simplify if you can. This would be cosine plus 1. And then if it doesn't simplify, move it in front of the cosine. So 2 cosine plus 1. What do we do next? Set them both equal to 0. So when we set them both equal to 0, I'm going to solve in the same step, but just be careful if you do it all in once. So cosine is equal to negative 1, and cosine is equal to negative 1/2. Cosine tells us we look at what on the unit circle? The x value. Where do we have an x value of negative 1? So let's go to our unit circle. You said pi, perfect. Anywhere else? Nope. So we'll say x equals pi. And then where do we have the x value of negative 1/2? 2 pi over 3 and 4 pi over 3. Perfect. So let's add those to our list. 2 pi over 3 and 4 pi over 3. All right, next let's do 15. So 15, we have one of those multiple angle ones. Cosine's already all by itself, so since our trig function's already isolated, we can look at our unit circle from here. Cosine tells us we look at what on our unit circle? The x value. Where do we have an x value of negative 1/2? 2 pi over 3 and 4 pi over 3, perfect. But instead of just saying x equals 2 pi over 3, we're going to say 2x equals 2 pi over 3. And 2x equals 4 pi over 3. Now, how would we get x all by itself? Divide by 2. What do we do when we have a fraction in a fraction? Keep, change, flip. So dividing by 2 is the same as multiplying by 1/2. So we can just multiply straight across. What do we get when we multiply? Pi over 3, perfect. The 2's are going to cancel, so this one simplifies. So always just double check. If you want to multiply it together first, double check to see if it can be simplified. So we get 2 pi over 6, which simplifies to pi over 3. What about in the second one? We would get 4 pi over 6, which simplifies to what? 2 pi over 3. Perfect. So these would be our 2 answers. So 21, we want to use the sum and difference formulas to find the exact value. I'm going to copy and paste my sum and difference formulas here. So you're going to get the sum and difference formulas. So you don't have to memorize them. You just need to know how to use them. So we want to see what 2 numbers either add up to 11 pi over 12 or subtract to 11 pi over 12. Now, it might be a little bit easier. Convert this to degrees first. So I'm going to multiply by 180 over pi. So pi's canceled. 12 goes into 180 how many times? 15, perfect. Or if you want to start smaller, divide them both by 2 or 6, if you don't see that right away. Then we have 15 times 11. I believe you, but I'm going to multiply it out. So we get 5, 1, 0. Awesome, 165. So this would be 165. Now 165 is not on the unit circle, but we can come up with 165 either adding 2 numbers on the unit circle or subtracting 2 numbers on the unit circle. What 2 numbers on the unit circle either add to 165 or subtract? There are more than one correct way to add together. I heard 135 and 30. That works. If you wanted to say, Jack, what did you say? 120 and 45. That also works. You'll end up with the same answer at the end. It doesn't matter which 2 you pick. Just make sure you pick 2 that either add to 165 or subtract. So we'll do 135 and 30. So sine of 135 plus 30. So since we're adding these together, we're going to use our sine formula where we're adding. So that's the first one. So it's going to be sine of u times cosine of v plus cosine of u times sine of v, where the first number is going to be our u and the second one is going to be the v. Now again, if you said 30 plus 135, it doesn't matter. When you're adding, the order doesn't matter which one you have your u and your v. Just make sure you're consistent with it. So just make sure you're organized and consistent. So sine of 135 times cosine of 30 plus cosine of 135 times sine of 30. Now we're going to use our unit circle to find each one of these. So sine tells us we look at what on the unit circle? The y. What's our y value at 135 degrees? Square root 2 over 2. Perfect. Cosine of 30. Cosine tells us we look at the x value. What's our x value at 30 degrees? Square root 3 over 2. Perfect. Plus cosine of 135. Cosine tells us we look at the x value. What's our x value at 135? Negative square root 2 over 2. And then sine tells us we look at the y value. What's our y value at 30? 1/2. So now when we multiply straight across, square root 2 times square root 3 would be square root 6 over 4. Then we have minus square root 2 over 4. And we can combine these together. So square root 6 minus square root 2 over 4. So that would be our answer. So 24 has two parts. We want to write each expression as a single trig function and find the exact value. So we're still using our sum and difference formulas. We want to see which sum and difference formula goes sine, cosine, then minus. So out of our formulas here, which one goes sine, cosine, then minus? The second one, sine, cosine, minus. So we have sine of u minus v. So the first number is going to be our u. The second one is our v. So sine of 315 minus 15. So this would be sine of 300 degrees. This is the first part of the question. So this is our first answer. This is writing it as a single trig function. Second part is we have to evaluate. I'm going to use my unit circle to find the sine of 300. So on our unit circle, 300 degrees would be here. Sine tells us we look at what? The y. What's our y value? Negative square root 3 over 2. So negative square root 3 over 2. Now if this were a number that was bigger than 360, to find it on the unit circle, you could always subtract 360. Or if it was a negative number, you could add 360 to find the coterminal angle. Any questions here? All right, last one, let's do 25. So we're going to find the exact value with the given conditions. We're going to find cosine of A plus B. So in the notes we did, this was cosine of U plus V. It's the same thing here, but instead of U and V, it's A and B, or alpha and beta. But we're doing the same thing. So we want to find all of our information for each triangle. We've got two different triangles here. We have an alpha triangle and a beta triangle, an A triangle and a B triangle. So in the first one, sine is what over what? 3 over 5, but what over what? Y over R. And it says it lies in the first quadrant, so let's draw it. So here's our triangle. Our Y is 3, R is 5. How do we find X? How do we find X? Pythagorean theorem. So 3 squared plus X squared equals 5 squared. Now remember, it's always equal to the hypotenuse squared, or your R squared. So it doesn't matter which order X and Y are in, but it has to be equal to your R squared. So we have 9 plus X squared equals 25. Subtract 9. So X squared equals 16. X equals what? 4. Is it positive 4 or negative 4? How do we know that it's positive 4? Because it's in quadrant 1. Our X is going to the right, so our X has to be positive. So in our alpha triangle, in our A triangle, we have X equals 4, Y equals 3, and R equals 5. Let's do the same thing for our beta triangle. So here are triangles in quadrant 3. Sine is negative 12 over 13. Sine would be what over what? Y over R. Is the negative with the 12 or the 13? How do we know that it goes with the 12? R is never negative, so the negative has to go with the 12. So we still need to find the X. So Y is negative 12, R is 13. How do we find our X value? Pythagorean theorem. So X squared plus negative 12 squared equals R squared, which is 13 squared. X squared plus, what's negative 12 squared? 144. What's 13 squared? 169. It doesn't hurt to know that off the top of your head, but if you don't know it, just write it out. Multiply 13 times 13. Subtract 144. X squared equals 25. Take the square root. X is equal to 5. Now, is x positive or negative? How do we know that it's negative? Because it's going to the left. Since our x value is going to the left, we know that our x is negative 5. So in our beta triangle, x is equal to negative 5, y is equal to negative 12, and r is equal to 13. So here is our information for both triangles. Now let's answer the question. So we have cosine of alpha plus beta, or a plus b. We need our cosine formula here. So cosine of u plus v is going to be this one here. So we're going to say cosine of a times cosine of b plus sine of a times sine of b. Now again, it uses a and b here, even though the formula uses u and v. If you want to just make the u's your a and the v's your b, you could do that. Or just make your a and b u and v. It's the same thing. It just uses different letters here. So let's plug everything in. Cosine is what over what? X over r. So cosine of alpha, we're looking at our blue triangle here, our A triangle. So x is 4 over 5. Cosine of beta, we're looking at the pink triangle, x over r. So that would be negative 5 over 13. Plus sine of alpha, we're looking at the blue triangle now. Sine is y over r. So what would sine of A be? 3 over 5. And then sine of B is y over r. What's sine of B? Negative 12 over 13. So we're going to multiply straight across. 4 times negative 5 would be negative 20. What's 5 times 13? 65. And 3 times negative 12? Negative 36 over 65. Let's add these together. What's negative 20 plus negative 36? Negative 56 over 65. Always double check to see if your fraction can be simplified. This one can't. So this would be our answer. So on your test, you're going to get everything from this page. So you'll get your identities, your unit circle, and your sum and difference formulas. So you will get this page.